So today, me and my group would like to present about study for DCC30093 Geotechnical Engineering. So before we start, I want to introduce my group member. First, we have Waybyern Liban Anak BRICKY. Next, we have Muhammad Najib Muhammad. The third one, we have Muhammad FAIZZUL bin JEFRI. And the last one, me myself, AUTHUR DAVIDSON NAGA. First of all, I would like to present about the introduction for Transient test. Transient is the most used method to measure the mechanical properties of deformable, especially rock and soil and other granular material or powder. The objective for Transient is to determine the shear strength parameter of soil, which are angles of internal friction and cohesion of soil with the shape changes of cohesive soil. Next, so this is example of graph of Mohr circle from the lab sheet. Apparatus and material that used in this Transient test is membrane stretcher, rubber membrane, sampling tube, Transient chamber, and rubber binder. So work procedure for Transient test. For the first procedure is 3-cylinder shape soil sample measuring 76 millimeter long and 38 millimeter in diameter are prepared. The second procedure is the sample are inserted into a rubber membrane and sealed on top bottom part using O-ring to prevent penetration into samples. A soil sample that is wrapped in the rubber membrane is placed into the Transient cell. Make sure that it is standing upright and steady on the center of the compression plate. The fourth one is what is inserted into the Transient cell through the intake valve until the whole cell is filled with water. The outlet valve is open to release the trapped air. Number 5, the valve on the Transient is closed and sample is imposed by 50 kilonewton meter square of cell pressure. Number 6, the reading on the deformation gauge and load dial gauge are set to 0. The test is started with loading rate of 1 meter per minute. Axial load added onto the sample until it fails, and proving reading that represents the Transient load is recorded for every 20 times 0.01 minutes standard dial reading that give the value of vertical transparency. Number 7, reading for every 0, 20, 40, 60, 80, and so on until the following instances occur, which is reduction of load gauge reading is next 3 reading of load gauge is constant and shift more than 20%. Procedure number 8 is the form of failed soil sample is sketched and mounted for every test sample is determined. Number 9, the same procedure above is repeated for other sample for cell pressure 100 kilonewton per meter square and 200 kilonewton per meter square. Number 10, the use proving reading number is noted and calibration data is obtained. The last procedure is stress and strain calculated for each reading, and a graph of stress versus strain and maximum shear strength for each sample is shown. Last but not least, model is drawn to determine the cohesion and friction angle. From the lab sheet, we asked to state and sketch type of failure. So the first one, 90 degree, which is no surface or bulging out. The second one is virtual slip surface, and the third one is 45 degree, which is 45 slip surface. So for the next part, I would like to pass to my group member. That's all from me. Thank you.
So hi, my name is NAJIB. So I'm going to present about the stress versus strain graph. As you can see here, we have two samples. For the sample one, we use dot to plot the graph, and for the sample two, we use X to plot the graphs. So as you can see in the graph, the sample one stress is more higher than the sample 2. So next, I want to move to the plotting of Moh cycle. So here we have three data. For the data 1, for the cell pressure, we get 50 kilonewton over meter square, and for the normal stress for data 1, we get 284.4 kilonewton meter square. So for the data 2, for the cell pressure, we get 100 kilonewton over meter square, and for the normal stress, we get 420.9 kilonewton over meter square. So last, we get for the data 3, for the cell pressure, we get 200 kilonewton over meter square, and normal stress for the data 3, we get 653.9 kilonewton over meter square. So this is the graph for the Mohs circle. So next, I would pass this presentation to Muhammad FAIZZUL to present more about this case study. Thank you.
Hi, my name is Mohammad FAIZZUL, and I will continue this case study by explain about the advantage of undrained traxial test. The first one is the stress distribution on the failure plane is uniform. The second one is the specimen is free to fail on the weakest plane. Next, there is complete control over the drainage. Next is pore pressure change and the volumetric change we measured directly. Number 5, the state of stress at all intermediate stage up to failure is known. The Mohr circle can be drawn at any stage of shear. And then the last one is this test is suitable for accurate research work and apparatus adaptable to special requirements such as extension tests and tests for different test paths. Then I will explain about the data 1. So we have length of sample base in millimeter and in meter. It is 0.076 meter. Next, sample diameter in meter, 0.038. The original area in meter square is 0.00134. And then the original mass of sample in gram, we have 128.54 gram. Mass of dry sample is 106.76 gram. And then moisture content, 20.40%. And then the cell pressure in kilonewton per meter square is 50. Then the last one is proving ring number is S317. So this is the data. We have deformation gauge, loading gauge, normal stress, strain, load, parts, so on. So we go to data 2. So length of sample in data 2 in meter is 0.076. The sample diameter in meter for data 2 is 0.038. The original area in meter square is 0.0134, same with data 1. The original mass of sample in gram is 130.54 gram. Mass of dry sample in gram is 104.18 gram. Content moisture content in percent is 25.30%. Next, we have cell pressure in kilonewton per meter square is 100. And then the probing number sense S370. You can see the data. So mini. And then the last one is data 3. So length of sample base for data 3 in meter is 0.076 meter. Sample diameter in meter is 0.038. The original area in meter square is 0.01134 meter square. Next, the original mass of sample in gram is 122.34 gram. Mass of dry sample is 98.76 gram. the moisture content is 23.88%. And then the cell pressure in kilonewton per meter square is 200. The proving number is the same as 370. So we have the same demonstrational gauge load, normal stress, strain, parts, load, and so on. So that's all from me. And I will pass the next slide to my group members, which is Waybyern, LIBAN, ANAK, BRICKY. Thank you.
Thank you, Mohammed FAIZZUL. Now I'm going to continue on size of footing. A square footing receives a lot of from the main structure with the value of 300 kilonewton. The depth of footing is 1.5 meter. So we will need to determine the size of footing if safety factor is 2.5. So as you can see, that is the diagram for the footing. Now we are going to move on to the solution. So from the table, bearing capacity factor is 23 degrees, and C is 21.75, and Q is 10.23, and NY is 6.0. So in order to find B, we will need to solve the ultimate bearing capacity first, which is QF. So the formula for QF is 1.3 CNC plus YZ and Q plus 0.4Y BNY. So after we substitute the symbol with the value, we will get 1972.71 plus 43.2B. Next, we will have to solve the ultimate bearing capacity, which is QFN. So for QFN, the formula is 1972.71 plus 43.2B minus 18 times 1.5 plus 0. So the answer will be 1945.71 plus 43.2B. Therefore, the width of footing B, using the formula 300 kilonewton over B squared minus 27 equals to 1945.71 plus 43.2B over 2.5. Then after we cross multiply and substitute, we will get the final answer, which is 43.2B power of 3 plus 1972.71 B power of 2 minus 750. So after we use simultaneous equation, we will get B equals to 0.6 meter. So for the conclusion, from this experiment, we learn about how to carry out the triaxial test. We also learn how to calculate the data such as mass of dry sample, moisture content, cell pressure, and so on with guidance from our lecturer. We also learn how to calculate the size of footing by using the formula given. During the test, we noticed a few advantages of conducting the triaxial test. For example, the test is suitable for accurate research work and the apparatus adaptable to special requirements such as extension tests and tests for different stress paths. In conclusion, although the test is quite tricky because it involves a lot of data, we were able to do it with consistent guidance and help from our lecturer. Last but not least, we hope that we can implement our knowledge and experience of doing this test when we are working in the future, because triaxial test is the most used method to measure the mechanical properties of deformable solids such as rocks, soils, along with other granular materials or powder. So that is all for our group. Thank you.